Previously we were discussing what polymer is, and polymer is a combination of small units, and we call that small units monomers. Monomers are small simple molecules that can be joined in a chain to form polymer. Carbon atoms can form up to 4 covalent bonds with other atoms, and so monomers are usually linked together by a covalent bond. The one important thing we must remember in polymers, when one monomer combines with other monomer, always a covalent bond will develop. So monomers are usually linked together by a covalent bond between carbon atoms. Most polymers contain a chain of atoms. The example of polymer which they are mentioning here is polyethene. Polyethene. They are also call it polythene. Polythene. Polythene is a polymer made up of a monomer, and the monomer in polyethene is ethene. Let me write in proper wording. Ethene. Ethene is monomer of polyethene. Ethene is monomer of polyethene. In the exam, they will give you monomer, they will give you a polymer, and they will ask you, please tell what should be the monomer for that particular polymer. What should a particular monomer for that polymer? What should be? What can be a particular monomer for that polymer? Right? So polymer molecule can have different length. Longer polymer have more intermolecular forces. Polymer molecule can have different length. Longer polymer have more intermolecular forces. So if the polymer structure is long, then it means it has high melting and boiling points. Polymer molecule can have different length. Longer polymer have more intermolecular forces between them. The longer chain also tend to get tangled up. Longer chain tends to get tangled up with each other. Longer chain, just take this example. I have this wire. If this wire is a long, and you see this wire tangled with each other. This wire gets tangled with each other. Similarly, when we have a longer polymer chain, then this longer chain also tends to get tangled with one another. For these reasons, longer polymer have higher melting and boiling points than shorter ones. Longer polymers have higher melting and boiling points than shorter ones, right? Very important points. Question will be asked from these lines that why longer polymers have high melting and boiling points, and why shorter molecules, shorter polymer chain have low melting and boiling point. The reason is the longer chain have high force of attraction. So the longer chains have higher melting and boiling points as compared to shorter chains. So this is ethene molecule. And when different ethene molecules combine together, we get polyethene. Let me write a polyethene structure for you. And first of all, let me write the polyethene structure for you. ethene. The structure of ethene is like this. C double bond. This carbon has double bond with this carbon, and there is a hydrogen, there is another hydrogen, and there is another hydrogen, and there is another hydrogen. Ethene molecule has 4 hydrogen and 2 carbons, and these 2 carbons are joined together by a double bond. By a double bond, you see, by a double bond. And this is a monomer. Now, how we obtain a polymer from it? What polymer is? Basically, polymer is a combination of monomers. One monomer combined with other monomer, and in this way, a different monomers. A large number of monomers combined together to make polymer. A large number of monomers combined together to make polymer. Just take this example. This is a monomer. Let me write this monomer like that. The simple is just draw the structure like this: carbon, carbon, carbon. Draw a longer chain of carbon. And put hydrogen here, 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 put hydrogen here. Then draw a bond here and draw a bond here. This shows that this chain can be extended. This chain can be extended. This is polyethene structure. This is polyethene structure. Polyethene, which is a polymer. Polymer. And what is the monomer of polyethene? The monomer, the name of the monomer which is present in polyethene is ethene monomer. Ethene monomer. So you get my point. Hope. So our next, just open that slide. Yes, ethene. You see, there is ethene. And this ethene converted into polyethene. They draw like this, but no matter, you can draw it straight as well. No problem. This is polyethene. Polyethene is a polymer. But there are a few questions, and these questions, I am pretty sure this question will be asked in exam as well. And the questions will be like that. What monomer is used to make polybutene? So what do you think that? Which monomer is used to make polybutene? Remember, to make polybutene, we need a monomer, and the name of that monomer is butene. The name of that monomer is butene. Okay. The other question is, what polymer is formed by linking styrene monomer? So the question is, you have a monomer and styrene monomer. First of all, you must know what styrene is. So let me draw styrene structure here. First of all, let me write the questions. What polymer is formed by linking styrene monomer together? First of all, let me write the statement of the questions at whiteboard. The question is, what a polymer is formed? Question B. It's question number 8. Question number 8, part B. First of all, let me write part A. Part A is what monomer, what monomer is used to make polybutene. A very simple answer. Butene. Butene. The name of the monomer is butene. Then the other question is part B of your textbook. You can check this in your textbook as well. What polymer is formed? What polymer is formed by linking styrene? By linking styrene monomer. By linking styrene monomers together. So first of all, we must know what actually the styrene monomer is. We must know, if we don't know what is the structure of styrene and what is styrene monomers and how can we know about the nature of the polymer and how can we know about the structure of the polymer. So let me discuss with you about styrene. The formula of styrene is C6H5CH double bond CH2, and we draw the structure like this. This is styrene. Put CH double bond CH2. So this is styrene. And this is the structure of styrene. This one. So if different styrene units combine together, which polymer is formed? The answer is very simple. It is polystyrene. The monomer name is polystyrene. And let me draw the structure in a simple way. First of all, draw a monomer, which is styrene, and then put a bond here, then put this hydrogen like this, and these two hydrogen like this, right? And then show this hydrogen here. Now draw a bond here and draw a bond here. Just this is structure of polystyrene. Put a bracket like this and put the small n like this. This is the structure of polystyrene. What we do, we just convert this styrene into polystyrene like this. Let me explain this. Usually carbon makes 4 bonds. We are also well familiar with the bonding and valency concept. Carbon makes 4 bonds. Carbon makes 4 bonds. So the structure of styrene is this. It has a carbon here, a hydrogen here, then double bond, and a hydrogen here and a hydrogen here. This is the structure of styrene. And we have to convert this styrene into polystyrene. So we have to convert this styrene into polystyrene. Nothing difficult, just once again draw the structure. And put carbon here, put hydrogen here. Now this is double bond. Convert this double bond into a single bond. Put carbon here, hydrogen here, and hydrogen here. Now this carbon has 3 bonds. And we now carbon makes 4 bonds. It means put a bond here. This carbon has 3 bonds. 1 bond this, 1 bond this, 1 bond this. It means 1 bond is missing. So put a bond here. This is polystyrene, because here we again put a monomer, here we again put a monomer. If we put a monomer here, it will become like this. Put C H H C H H. But this become a complicated structure for you, so let me erase it. Just make it simple. Put a square bracket here, and put N here. Don't forget to put this N. This is polystyrene. This is polystyrene. And now let me explain this N. Actually, the structure of styrene is this one. Structure of styrene is this one. Double bond CHH. And we convert this styrene into polystyrene. How? Just by combining styrene units together. Just by combining styrene units together. So just to draw a styrene here, like this one. Put bond here, put bond here, put carbon here, hydrogen here, single bond here, carbon and hydrogen here. Then this carbon has 3 bonds, and we know carbon has 4 bonds. Put a bond here, and again draw this carbon, hydrogen. Draw here another styrene unit. Draw here another styrene unit. Similarly, draw here another styrene unit. Like this one. Draw here another styrene unit. And we would, in spite of drawing so many styrene units, just put a bond here, just put a bond here, and close all these things in square bracket and put N here. N means different styrene units joined together. In spite of drawing 3 styrene units, sometimes we simply draw 1 styrene unit. Put a carbon here, hydrogen here, single bond here, carbon here, hydrogen here, a bond here, and just enclose this styrene unit into square brackets and put a small n here. This small n shows that so many styrene units join together. So this is the answer of your this one question, and the question is, what polymer is found by linking styrene monomer together? The answer is polystyrene. Simple answer is polystyrene. But if you will draw structure, this will definitely help you to get good marks. Now, the next question, question number 9 is, explain why most of the polymers are solid at room temperature, whereas their monomers are liquid or gases. The reason is because when we talk about polymers, polymer has definitely a long structure, a huge structure, and when a structure is big, it has a big structure. When a structure is big, this it means that it has a definitely a large number of forces of attraction, and when there is a large number of forces of attraction, it means that thing is solid. Right? Let me explain in proper wording. So the next question, which is question number 9. Question number 9. Let me write the statement of question number 9. Explain why most polymer are solids at room temperature whereas their monomers are liquid or gases. Whereas their monomers are liquid or gases. The answer of this question is, now polymer is made up of a large, polymer has a large structure because polymer is made up of a, by repeating so many monomers units. And when the structure is big, it has a large, huge force of attraction. And when there is a strong and huge force of attraction, then this substance is really in solid form. Let me write this answer. Polymers are made up of very large molecules, made up of repeating so many monomer units. Monomer units. Intermolecular forces. Intermolecular. Intermolecular forces. Intermolecular forces between polymer molecule are strong compared to intermolecular forces between small molecules. That is the reason polymer molecules are solid at room temperature and their monomer units are usually liquid or gases. So most polymers are solid. So most polymers are solids at room temperature. So the next question is, let me open your textbook for our next question. Explain why small molecule have lower melting point than large polymer molecule. What do you think about that answer? Answer is obviously in context of forces of attractions. Now, small molecules have lower melting points because they don't have huge forces of attractions. Let me write this answer in proper wordings. Why small molecule have lower melting point? Our concept is crystal clear, as these are also mentioned in that lines. Polymer molecule can have different length. Large polymer have more intermolecular forces. The longer chain also tends to tangle. Okay. But let us find another proper words. Why the question is why small molecule have lower melting points than large polymer molecule? Why small molecules have a lower melting point? A lower melting point than large polymer molecules. The answer is very simple and straightforward. Let me explain this answer according to your textbook. The answer is written in these lines. I am going to highlight these lines. You can highlight them in your textbook. Polymer molecule from here. A large polymer have more intermolecular forces between them. The long chain also tends to get tangled up with one another. For this reason, longer polymer have higher melting and boiling points than shorter one. This is the answer of your exam style questions. Answer of your exam style question. So this is our one topic, and our next topic is about allotropes of carbon. And we will discuss allotropes of carbon in our next class. Allotropes of carbon, properties of metal, which is another topic. Okay, if you have any questions, feel free to ask me that question. Let me share these pages with you. 2, 3.